Okay. So today we're talking about applications. We've talked about that word applications before. What's the word applications mean? It means we're applying what we learn. So typically when we see that we're going to do applications, it means what kind of problems?
Distribution,
Say again.
distribution problems,
Distribution problems, systems. These are applications of systems, but what does the word applications in mathematics typically mean? It means we're applying what we learn in the form of what? What kind of problems do you see? Word problems. Yeah, these are going to be all word problems. Okay, so let's start off with our I can statement. I can write a system of linear equations for a real world situation and solve using substitution and elimination. So I can write a system of linear, I'm going to make those not look like cursives. I can write a system of linear equations for a real world situation and solve using substitution and elimination. So the thing about our real world situations is when we read a real world situation or a real world problem, or even if it's just a word problem that we have to use variables for, we have to define our variables. If it's not defined for us in the problem, we have to define them. Okay. Does anyone need that I can statement up there anymore? Good. Okay. So write a system of equations for the real world scenario and solve. Define your variables. So the sum of two numbers is 92 and their difference is 20. Find the two numbers. Remember that the question, what are we trying to find? What are we looking for? That's our variable. So what are we looking for? Two numbers. What do you want the first number to be? How about x? Let x equal the first number. We're going to let y equal the second number. So let's look at our equation. The first one, the sum of two numbers is 92. Well, I know the word is an equal, and I know that sum means addition. So what am I writing? What's my equation going to look like? If the two numbers that I'm talking about are x and y. Owen?
x plus y equals 92.
Perfect. X plus y equals 92. The second equation says their difference, they're referring to the two numbers, is 20. Their difference is 20. So I know that the word is means equals, and difference is a subtraction problem. So how do I show that their difference is 20? Huh? What are the two numbers we're talking about? We're talking about the two numbers x and y, right? Our two numbers are x and y. So how do I show that I'm going to take the difference of x and y? X minus y, that's difference, is 20. So those are our two equations. So these are the equations. God bless you. These are the equations for your system. So what method do you want to use to solve them? Do you want to use elimination or substitution? Which one do you think would be best? Which one are we set up for? Yeah, we're set up for elimination. We have X and Y on one side, the constant on the other, and we even have opposite coefficients. So I'm going to rewrite this whole system. X plus Y equals 92, and X minus Y equals 20. Tim, you want to walk us through, since you said use elimination? What do you want to do?
You get rid of the y because since they're opposite, they cancel each other out.
So we're going to add the equations together, and that'll eliminate the y's. And what does that leave me with?
2x or 2x equals 20. Or not 20. 112.
112. Okay. Now what?
You divide both sides by 2. X.
Just divide both sides by 2, and I find out that X equals 56, right? X equals 56. So I found one number. How am I going to find the other number? Okay, which equation do you want to work with? The first one? So Ariana says, hey, take that first equation and you're going to substitute in 56 for X. So 56 plus Y equals 92. What do you want to do next, Ariana? Because that's perfect. Yeah, subtract 56 from both sides. And I find out that Y equals 36. So word problem makes us have a word statement. The two numbers are 56 and 36. How do we feel about that? Good? Okay. Can we go to the next one? The difference of two numbers is 16. The greater number is 5 less than 4 times the smaller number. Find the two numbers. So what are our variables going to be? What are we looking for? What are we trying to find? We're trying to find two numbers, right? What do we know about the two numbers? One of them is what? One of them is, and the other one is smaller. So which one do you want to be the greater number? X or Y? Okay, so let X equal the greater number and let Y equal the smaller number. So that first statement says the difference of two numbers is 16. What's that going to look like? Difference means what? It means subtract or minus. And is 16. That just means equals 16. So what are we going to do? What are we going to write? Perfect. X minus y equals 16. Okay, the second statement is a little harder. It says the greater number is, so whatever variable represents the greater number is equal to, is means equal. So what variable is the greater number? X. So X is means equal, 5 less than 4 times the smaller. How do we show that? 5 less than 4 times the smaller. It's not 4 minus 5, 4 times the smaller. 4y minus 5. Good job, you three. Nice job talking it out. 4y minus 5. So this is our system. This is our system. Those are our two equations. What method do you think we should use to solve for this one? Yeah, I think that we should use substitution because we already have a variable term isolated. So we already know that x is 4y minus 5. So I'm going to take this 4y minus 5 and I'm going to use that and replace it in the first equation. So x minus y equals 16. But we said that x is 4y minus 5. So that's what I'm doing. I'm replacing x with the expression 4y minus 5. Minus y equals 16. What can we do on the left side? Can we do combining in any like terms, or what can I combine? So what is 4y minus 1y? So 3y minus 5 equals 16. Isaac, what would you do next?
Add 5 to both sides.
Yeah, add 5 to both sides. 3y equals 21. Kenna, what would you do next? Divide both sides by 3. So I find out y, the smaller number, is 7. Okay. How are we going to find x, the larger number? What question do you want to plug it into? What equation? The first one or the second one? The first one. So our first equation, x minus y equals 16. But we just learned that y is 7. So x minus 7 equals 16. What do you want to do next? Absolutely. Add 7 to both sides. So x equals 23. That's the larger number. Is 23 larger than 7? Good. So we set that up right. So we have to give a word statement. Here, let me rewrite that. Sorry. Okay. The larger number is 23 and the smaller number is 7. The larger number is 23 and the smaller number is 7. Okay, I need someone to read example number 3. Owen, go ahead. Thank you.
The roller coaster has 15 cars, some that hold 4 people and some that hold 6 people. there is room for 72 people altogether. How many 4-passenger cars are there? How many 6-passenger cars are there?
Okay, so what are we trying to find? Our variables have to be what? We're trying to find out how many what?
4 passenger cars and 6 passenger cars.
Okay, so we have to let x equal, how many means the number of, right? Number of 4-passenger cars. And if x is the number of 4-passenger cars, then y is what? Yeah, number of 6-passenger cars. So how are we going to get our two equations for our system? How many cars are there altogether?
There's 15.
There are 15. So how do I show that the number of 4-passenger cars added to the number of 6-passenger cars equals 15?
X plus 6 equals 15. Or X plus Y.
Yeah. Our first equation is just x plus y equals 15, because x is the number of 4-passenger cars. So however many 4-passenger cars we have plus however many 6-passenger cars we have is equal to 15. It's that second one that's kind of tricky, and it has to do with the number of people, because there is room for 72 people altogether. So whatever our next equation is has to do with the number of people. There's room for 72 people. So how many people can ride in a 4-passenger car? How do I show that? How do I show that I can put 4 people in a 4-passenger car? Mm-hmm. And then the number of people that ride in a 6-passenger car are how many? So let's talk about why this makes sense. Remember that X is the number of 4-passenger cars. So if I have 5 4-passenger cars, 4 times 5 is 20 people. Y is the number of 6-passenger cars. So if I have 10 6-passenger cars, 6 times 10 is 60. That means that would be 60 people. So number of people has to equal number of people. All right, so how do we want to solve this one? What method do you want to use? Any ideas? Elimination? Was that you, Lissandro? I totally agree. So this is our system. Lissandro, if you want to use elimination, what are you going to change? What are you going to, God bless you, do to use elimination? Say again. Take what 4 times 1? What equation? So the top one? So the top equation, Lissandro is saying take the top equation and multiply it by -4. So let's do that. Let's see. -4 times x is -4x. -4 times y is -4y. -4 times 15 is -60. Are we changing the second equation? No. 4x plus 6y equals 72. All right, let's solve this. What's going to cancel out when we add these two together? Yeah, we're going to cancel out our x's. God bless you, sir. So when I cancel out my x's, negative 4y plus 6y gives me, and negative 60 plus 72 gives me, okay. Keep going, Tim.
Divide both sides by 2.
And I find out that the number of 6-passenger cars is 6. 6 passenger cars, okay. How are we going to figure out the number of 4-passenger cars?
Sum the 6 to the equations.
Which one do you want to put it into?
Bottoms.
I'm going to put it into the top one. Less work. X plus y equals 15. We just said that y is 6. So x plus 6 equals 15. Subtract 6 from both sides. And I find out that x equals 9. What does the x represent? So there are 9 4-passenger cars and 6 6-passenger cars. Let's see if that makes sense. 9 plus 6 is 15. That's our total of 15 cars. And 9 times 4 plus 6 times 6 is 72. Yeah, that makes sense. Are we good with that one? This next example, example 27, I don't know why, but money questions always seem to be some of the hardest for you guys. Money questions always seem to be some of the hardest. Does anyone still need example 3 up? Okay. Someone other than Owen needs to read. Please and thank you.
Jonathan has 27 coins that are all dimes and quarters. The value of the coins is $4.35. How many dimes and how many quarters does Dante have?
So what are we trying to figure out? So X is the number of dimes, right? How many means number of? So let X equal the number of dimes. And then we can let Y equal the what? Number of quarters. All right. Let's talk about our equations. What do you think? Aiden, what do you think? If you had to write the first equation. How many coins does he have altogether? So how can you show that the number of dimes and the number of quarters is 27? Isaac, help out.
X plus y equals 435.
X is the number of dimes, not how much a dime is worth. It's just the number of dimes. Yes, there's a pattern. All of our equations have been set up like this. X plus y equals 27. The first equation in your system usually tells you how many of something you can have. And then the next one deals with the unit of measure, typically, like the last one, our unit of measure was like number of people in passenger cars, right? Here, our unit of measure is money. So how much money is a dime worth? 10 cents. How do I show that in terms of dollars? Because my answer is given to me in dollars. So whatever we do has to equal 4.35. That's in terms of a dollar. So how do I show that a dime is? Okay, but that's in pennies. 10 pennies and I need it to be in dollars. How do I show that 10 cents equals some kind of dollar? How do you show 10 cents in terms of a dollar? So 0.10, isn't that how 10 cents looks like on a receipt? So 0.10 times X plus, how do I show a quarter? 0.25. There. So those are your two equations for your system. Those are your two equations for your system. So how do you want to solve those? What do you think, Avery? What method do you want to use? Okay. Daniel, what method do you want to use? Your two methods are what? Elimination and substitution. Substitution, we typically only use that if we have one variable already isolated. Do we have one variable already isolated? Elimination we use when we've got both the x's and the y's on one side. Do we have that? Yeah, and that's what Daniel said, use elimination. Okay. So we're going to use elimination. So I'm going to rewrite both equations really fast. X plus y equals 27 and 0.10x plus 0.25y equals 4.35. We typically don't like working with decimals, do we? You like working? No?
No.
Decimals are kind of tough. So what could we multiply that bottom equation by to get rid of all the decimals? Or to move all the decimals? I want to move all of the decimals. So think about your base 10 number system. What is something that I can multiply everything by so that all of the decimals move over 1, 2 places? So that would be 10x. 1, 2 places, that would be 25y. 1, 2 places equals 435. Every time you move a decimal place, you're multiplying by a. If I multiply by 10 by 1, do I move anything? What's 1? So then the next place value is the tens place. If I multiply by 10, if you take 4 times 10, what do you actually add to that number? So you're adding a what? A 0. So look, think about how decimals work. If I take 4.0 times 10, I actually get 40.0. So if I have 2 decimal places, like 4.25, what do I have to multiply by to make that decimal move over 2 times? 100. Every 0 that you multiply by moves the decimal that many units. A number with 2 zeros moves it 2 units. So if I had the number 4.075, I would multiply by 1,000. Yes. So if we multiply the bottom equation by 100, we can get rid of all of our decimals. So we're kind of thinking out loud for a second. We're going to multiply by 100 on the bottom equation to get rid of all of our decimals. So that would leave me with a 10, excuse me, a 10x and a 25y. So what do you want to get rid of in the top? Do you guys want to eliminate x's or y's? I say we eliminate x's and we multiply the top equation by negative 10. That will let us have an opposite same number. So let's kind of do this. So negative 10 times x is negative 10x. Negative 10 times y is negative 10y. And negative 10 times 27 is negative 270, right? Okay. So when I multiply by 100, I'm actually just moving the decimal over 2 times. Positive 10x plus 25y equals 435. Okay. So now what? Okay, so x's are gone. What is negative 10y plus 25y? 15y equals, what is negative 270 plus 435? 165. Okay, divide both sides by, and you find out that y equals 11. That means that I have 11 quarters. 11 quarters. Let's figure out how many dimes we have. How are we going to do that? Okay, do you want to plug it into that first equation or the second one? The first one, yeah. The second one has decimals. We don't want to work with that again. X plus y equals 27. But we just said that y is 11. So x plus 11 equals 27. Subtract 11 from both sides, and I find out that x equals, so Dante has 16 dimes and 11 quarters. Dante has 16 dimes and 11 quarters. Two more examples. Raise your hand if you still need example number 4 up there. Okay. So someone other than Ariana and Owen, I need a volunteer for example number 5. Who's Lissandro, please and thank you.
The geometry teacher had a set of 60 classic pentagons and octagons. She happened to notice that all the figures together have a total of 354 sides. She had lots of squares on it. How many of each shape are there?
So Lissandro, what are our variables going to be? It's asking how many. That means number of. What are our shapes? So what do you want x to be? So x is the number of pentagons. And that means that we have to let y equal the number of octagons. All right, Eden, I'm going to go back to you. How many total plastic shapes does she have? She has 60. How do I show that? Perfect. X plus y equals 60. All right, Tyler. How many sides? Because the next one is total sides. So whatever we do has to equal the total number of sides, which is 354. How many sides does a pentagon have? Help them out. Anyone? Penta? Huh? 8? Nope. Penta? A hexagon has 6. Pentagon has 5. So that's going to look like 5 times x. 5 sides per pentagon. That's what that looks like. 5x. 5 sides per pentagon. Plus, how many sides does an octagon have? 8. 8 sides per octagon. 8y. So those are our equations for our system. What method do you think we can use to solve it? Elimination, I agree. So I'm going to rewrite the system. X plus y equals 60. 5x plus 8y equals 354. So Tim, what equation do you want to change so we can use elimination? What do you want to multiply by?
Multiply the top one by -5.
I'm going to multiply the top one by -5, and I'm not going to multiply the bottom one by, I'm not changing the bottom one at all. So I'm just going to write that I'm multiplying by 1. I showed you guys this last week, right? One of your elimination activities in Delta Math asked you to, what are you multiplying by? Okay, so let's see. -5 times x is -5x. Yeah. -5 times y. And -5 times 60 is, what's 5 times 6? 30. Add a 0. So -300. We're not changing the bottom equation at all. So multiplying by 1 just is the same thing as not changing it, right? We keep everything the same. So 5x plus 8y equals 354. So when I add these two equations together, what variable gets eliminated? Yeah, we eliminate the x's. What is -5y plus 8y? 3y. And what is -300 plus 354? Divide both sides by, and that means that y equals 18. So we have 18 octagons. We need to figure out how many pentagons we have. 18 octagons, we need to figure out how many pentagons we have. How are we going to do that? So which equation do you want to put that into? Top one. Okay. So x plus y equals 60. But we know that y is 18, so x plus 18 equals 60. What are we going to do next? Subtract 18 from both sides. And I find out that x equals 42. So this geometry teacher, I'm assuming that it's a she because I'm a she. So she has, but it could be he. She has 42 pentagons and 18 octagons. I'm going to write a little. Is anyone still writing that down? If you are, I'll wait. Okay, I'm going to just write some notes up here just in case. So I'm going to call this number of sides. Triangle has how many sides? Quadrilateral has how many sides? Are we sure? Yeah, should be. We did a big old assignment on quadrilaterals, right? We spent a lot of time on that. Pentagon has how many sides? Hexagon has how many sides? You guys would never get this, but a septagon, 7. Yeah, weird. I know. Octagon, decagon. Yeah, 10. We'll stop with that. Really, you shouldn't have anything bigger than an octagon ever. And you probably will never see a septagon or decagon, right? But a hexagon, you should know that has 6 sides. An octagon, that's a stop sign, right? I think that's spelled wrong. Octagon. So a stop sign is an octagon, 8 sides. and a pentagon, 5 sides. So number of sides, that's kind of a hint in case you get a question about maybe a hexagon and a triangle. You know the number of sides, okay? Let's look at our last example. I need a reader, someone who hasn't read yet. Kenna, you want to read for us? Please and thank you. Okay, so what are our variables? How many means what? What does the phrase how many mean? The number of. How many means the number of when we define our variables, okay? So what are we looking for? The number of what? In each kind of cookie. So what kind of cookies do we have? Okay, so let's let X equal the number of calories in a lemon cookie. And that means that we're going to let Y equal the number of calories in the fudge cookie. So Y is the number of calories in a lemon cookie, or sorry, X is the number of calories in a lemon cookie, and Y is the number of calories in a fudge cookie. So what do you think our first equation could be?
X plus Y equals 400.
Read that again. Look at what I have underlined.
3x plus 2.
Yeah, 3x plus 2y equals 400. Okay. And then what's our next equation going to be? Someone other than Tim. Next equation. How many lemon cookies are we using? It's underlined in black. So what'd you say, Avery? So 2x plus, how many fudge cookies, Avery? So what does that look like? Equals how many calories? Good job. Okay. What do you want to do? How are we going to, what method do you want to use? Do you want to use elimination? Do you want to use what? Elimination. I'm going to label this as our system. Everybody's good with elimination? Okay, so I'm going to rewrite our equations. 3x plus 2y equals 400. 2x plus 3y equals 425. How do we want to manipulate those equations so we can cancel something out?
Multiply the top by -2 and the bottom by 3.
Multiply the top by -2 and the bottom by 3. Okay, I think that's a great idea. Let's see. -2 times 3x is -6x. -2 times 2y is -4y. And -2 times 400 is -800. 3 times 2x is 6x. 3 times 3y is 9y. And 3 times 425 is 1275. So when we add these two equations together, we are going to eliminate our x's. We're eliminating our x's. -4y and a +9y equal 5y. -800 and a +1275 give me 475, right? Divide both sides by 5, and what do I get? Yeah, y equals 95. So that means that a fudge cookie has 95 calories. How am I going to figure out how many calories are in a lemon cookie? Okay, so what equation do you want to substitute this into? Top equation. So 3x plus 2y equals 400. But we know that y is 95. 3x plus 2 times 95 equals 400. So 3x plus, what is 2 times 95? Equals 400. Now what? Subtract 190 from both sides. So 3x equals 210. Divide both sides by 3, and I find out that x equals 70. So what's our word statement going to be? A lemon cookie has what? Perfect.
And and the fudge cookie has 95.
I love that. Perfect. A lemon cookie has 70 calories and a fudge cookie has 95. Absolutely perfect.